So this is some extra solving practice to help you with what we did on page 82. I said that I would do a couple just if you needed a little extra support, make sure you feel good about what we did for solving. So the first one I'm going to do is question number 5 from the right-hand column. And that question is 2x squared plus 3x minus 14. And my goal is to find the roots. So the first thing I look at is if there are any common factors. They do not all have x, so I can't factor out an x. They are not all divisible by the same number. So I don't have anything special that happens with this one. I'm just going to go straight to using the box method. So in the box, this top corner is going to be 2x squared. The other corner will be negative 14. And I need to determine, using the 2 and the negative 14, what number I'm going to try to break down. Well, 2 times 14 is 28. Since it's 2 times negative 14, that's going to be negative 8. And my goal is to figure out factors of 28 that I can multiply together to make 28, but add together to get 3. Well, 2 and 14 they're not going to work. They're way too far apart. It will not combine to make 3. So the next one that comes to mind is 7 and 4. Well, 7 times 4 gives me 28. I need negative 28, but these need to combine together to get me this middle term. So they need to add to make positive 3. So the smaller number needs to be negative. So the 4 needs to be negative. So I'm going to put 7x and negative 4x into those empty corner boxes. And now going from the inside out, we're going to look for our greatest common factors. I'll just zoom in a little bit, make sure you can see what's going on. So this this column right here, 2x squared and 7x, all they have in common is an x. Negative 4x and negative 14, they are only both divisible by 2. Since both of them are negative, I'm also going to make that a negative 2. Coming out this way from this row, 2x squared and negative 4x, they both have an x and they're both divisible by 2. And then the last row, I have 7x and negative 14. So that's going to be positive 7 since they're not both negative. If you did a quick double check just to make sure, going from the outside in, everybody multiplies to make the corresponding box. So my factors will be 2x plus 7 times x minus 2. And that needs to be set equal to 0 because my goal is to find the roots. So in this case, I'm going to think about both of those things being separate. My goal is to determine what value of x would turn this factor into 0 and what value of x would turn this factor into 0. I'm going to start with this one. There's a lot less work here to do. I just add 2 to the other side, so that tells me that this factor would be x equals 2 to create a factor of 0. On this side, I'm going to have to subtract 7, and then I'm also going to have to divide by 2 because I'll get 2x equals negative 7. And then I'll need to divide by 2, and I will get that x is equal to negative 7 halves. So there are my 2 roots. The next one that I thought I would do is question number 8 from the right-hand side. So for question number 8 from the right-hand side, I have 6x squared minus 13x plus 6 being equal to 0. Looking at these 3 terms, they're not all divisible by the same number. They have nothing in common, so I'm going to go straight to the box. So here I have 6x squared and 6. So because this is a case where I have a leading coefficient or a number out in front of x squared, I do have to break down 6 times 6, which gives me 36. And somehow these two things have to combine together to make my center term of negative 13. Well, if I did negative 6 and negative 6, that would multiply to get positive 36, but that would only combine together to make negative 12. So I have to go back and think about other factors of 36 that we know of that could potentially add to 13. 6 and 6 is usually the most common one for our brains to go to. The next one I usually go to is a 9. So 36, if I divide 36 by 9, that would be 4. Well, yes, 9 times 4 does give me 36, but 9 plus 4 only gives me 13. But I need it to be negative 13, not positive. So both of these things need to be negative. So those are my empty corner boxes. And now from the inside out, I want common factors. So I'm going to start with rows. 6x squared and negative 9x. 6 and 9 are both divisible by 3. Both of those terms have x. Here I have negative 4x and 6. Both of those things are divisible by 2. Going straight up in this column, both of those coefficients are divisible by 2. And they also have x's that I could divide out. And here, these are divisible by 3. The issue is these two corner boxes are negative. So I need to make sure that both of those constants are negative so that when I multiply them together, I get positive 6. So my factors will be 2x minus 3 and 3x minus 2. So since these are the only two factors I'm dealing with, these are the two things we need to solve for. X, and figure out what value of x makes each of these equal to 0. In this case, I'm going to add 3 to get 2x by itself, and then divide by 2 to get x being equal to positive 3 halves. Here, I'm going to add 2 to the other side, and then divide by 3. So here I'm going to get x is 2/3. And those two values would be our roots. I thought I would do a few questions that had more of a special case involved. So the first one we'll do is, we'll actually just go right to the next one, to number 9. And we'll do number 9 from the right-hand side, which is 5x squared minus x equals 0. The coefficients, I have a 5 and a 1. They don't have anything in common, but these both have x's. So if I factor out an x from each of these, I got to figure out what would be left to multiply to get back to that same term. So here I've factored out an x. So x times what gets me 5x squared? Well, I would need to multiply by 5, and I would need to multiply by x, and that would create 5x squared. Here, x times what gives me negative x? Well, I need to multiply by negative 1 in order to make that happen. So I factored x out of both terms. So x would be what's outside of the parentheses. And then 5x minus 1 is what's left over. Both of those things are set equal to 0. Solve both of these to determine what x values make 0. Well, that would be 0 because it's just x. Here I've got 5x minus 1. Add 1, so I have 5x equals 1. And divide by 5, so I have x equals 1/5. So those are my solutions there. So the last one I'm going to do from the speed dating page is number 10 from the right-hand column. So I have 3x squared minus 3x equals 0. Both of these I can factor out a 3, and I can also factor out an x. So 3x times what gives me 3x squared? Well, the only thing missing is one more x. And then here, 3x times what gives me negative 3x? I would need a negative 1. So these two things are going to be, this 3x is the thing that I factored out of both terms. So that's the thing that's going to go outside of the parentheses. And then the other two portions are the leftovers. That's going to be what's still inside of the parentheses. And that is set equal to 0. And now my goal is to determine, since both of these two factors involve x, what would make 3x equal to 0? Well, that's if x is equal to 0. That's the only opportunity we have. Or what would make x minus 1 equal to 0? And my only way for that to happen is if x is equal to 1. So that would be my answer there. The reason I couldn't go any farther from this step is if you look here, both of these x terms have an exponent of 1. If it was an exponent of 2 here, for example, if I could only factor out a 3, I would have more work to do. But since I could factor out an x, leaving me with just x here, we didn't have to go to the box from there. I have 2 examples to do that involve factoring out a value, and so we can see what that does, but not factoring out an x. If you want to put these with your notes from page 80, or you want to add these to your notes or to your practice on page 82, that's totally fine by me. We're going to look at 2x squared plus 14x plus 20. We'll look at this one first and see what happens. So, all right, I had some technical difficulties there. So if you look at all 3 of these, they are all divisible by 2. So I'm going to factor that out of everybody. So 2 times x squared would get me back to 2x squared. 2 times 7x would get me back to 14x squared. And here I've got 2 times 10 to get me back to 20. 2 is what I factored evenly out of all 3 of those things, all 3 of those terms, I'll use my proper math vocabulary. So x squared plus 7x plus 10 is what's left over, and that's all going to be equal to 0. This trinomial inside of the parentheses is what now we need to factor. I'm going to zoom out a little bit, give myself some more room. So I am going to factor x squared plus 7x plus 10. So x squared and positive 10 are the boxes in the top corner and the bottom right corner. I got to break down 10 to somehow add up to make 7. The only way that can happen is if I do 5 and 2. So I'm going to have 5x and 2x. To get from the inside out, we need to do our greatest common factor. So between 2x and 10 would be 2. Between x squared and 5x would be x. Between x squared and 2x would be x. And between 5x and 10 would be 5. So my factors are x plus 2, x minus 5, and I have to bring back the 2 from the beginning that I factored out. Set that whole thing equal to 0. So now my goal, or now my mission, is to take each of these terms and determine what x value would make that term equal 0. If you look at this first portion that I factored out, there is nothing here that is dealing with x. So no matter what these two factors turn out to be, this is going to remain 2. That 2 can never be manipulated to be 0 unless something over here turns out to be 0. So this 2 is out of the ballgame. So I'm only dealing with x plus 2 and figuring out how that could potentially be 0, and x minus 5 and figuring out how that could be 0. My only opportunity here is if x was equal to negative 2. Similarly here, it could only be if x was positive 5, and those are my 2 roots. So the biggest difference between these two problems that we just did is this common factor outside that we took out of everything before we even started with factoring anything else. Here, since this had an x, that was something I needed to set equal to 0 to determine what x value would make that factor 0. However, in the second problem, this had a 2 that got factored out, not an x, so there's nothing I can do to manipulate this to make that equal to 0. And that's the biggest difference there. If it has an x, I do need to work with it and figure out what x value makes that 0. If it doesn't have an x, it's chilling by itself. Nothing we do is going to make that equal to 0, so I let it be.